point, I'd like to introduce Mal Rojas, who will be presenting the tutorial bringing true load balancing to your on-premises Kubernetes cluster. Mal is a network automation consulting engineer for Nokia and is coming to us today from Texas. This is Mal's 5th time presenting at NANOG. His last talk was at NANOG 88, and that was a tutorial of the PyGNMI and ChatGPT to troubleshoot EVPN Datacenter Fabrics in Seattle. Welcome out, Mal. It's a pleasure to have you back with us today.
I was working as a consulting engineer, but 3 months ago my role changed. Now I'm in optical and IP automation. It's nice, but I don't know so much about optical. I'm still catching up, but it sounds very, very interesting. At the time that I submitted this presentation, I was working pretty hard on Containerlab, UNMIC, or that kind of technologies. And who is familiar with Kubernetes here? Okay, perfect. And then who is familiar with Containerlab? Oh, more people. That's nice. Well, I'm gonna show you, this is my experience, and I'm not actually an expert in Kubernetes, an expert in Containerlab. This is about what I've been discovering on my own. Every time that I want to try a use case. I've been working with Containerlab for a while, almost a year and a half or maybe 2 years. And I've been doing many projects. Lately, I've been working more with MPLS, segment routing, things like that with Containerlab. It's pretty amazing all the things that you can do with this. And but before that, and this is why the topic of this presentation, I was working with a data center. In this case, I'm working with the VPN. And I'm gonna show you something that I actually, when I was working with some customers, they tried to use Kubernetes, and every time that they're trying to create a load balancer service in Kubernetes, it was sort of an issue for them. It wasn't that automatic. Then I'm gonna show you what I did for some customers to show them that actually there are products or open source projects that you can use for that and can simplify and automate also the way you can create a Kubernetes service for load balancers, okay? Well, in the abstract, I'm saying is when you install Kubernetes and you want to try to use any of the services, like for example, cluster IP is the default service that you have in Kubernetes. But when you want to expose any of your applications, you need to use something like node port or load balancer. And when you install Kubernetes, you see that actually load balancer is a type of service that is there, but it's not working. Only the node port is the only option that you have so far to start working with on-premises solutions. And then looking for a solution that can help us to have a really easy way to expose services using the load balancer, I found MetalLB. I'm talking about almost a year and a half ago. And I saw many people actually using it. But many people was using it as a layer 2 option because they didn't want to depend on the fabric, on the network, in order to start exposing the services. Then, but I saw also they had a BGP option, and this is the one that I'm going to present today. How you can turn your Kubernetes nodes into a BGP neighbor or peer to your fabric and start exposing the services through a load balancer Kubernetes services in an automated way. Then you don't, it's like a sort of resolving the problem. If I want to expose some services, I don't want to pick the phone and call the network guys. Hey, I need you to go and set up something for me in the load balancer, because the idea is make this very automated, right? Or Kubernetes, at least, is for that. And when you are working with the public cloud and you create your Kubernetes cluster over there, everything is actually working right away. You can just go and start using the load balancer service with the load balancer that actually the public cloud is providing in the case of Google Cloud or Amazon. Then when you had a fresh installation of Kubernetes cluster and you try to use the load balancer service because it's there, it's gonna show you that it's in a pending state. And basically this is happening because it's there, but it's not working until you can connect or integrate that with any of the load balancers, okay? And for that, I did this session where I'm gonna bring an introduction of Kubernetes services for who is not very familiar with that. I'm gonna talk a little about MetalLB, what is the project, okay? And the different ways that you can actually set up this. There is another thing that it was very useful for this, Kubernetes Kind. And at first, when I was doing my labs with Kubernetes, I was actually installing Kubernetes in virtual servers and trying to emulate like some sort of a virtual wire between the virtual servers and the containers in Containerlab. It was a little messy. And then I discovered Kubernetes Kind. That's another open source project that is going to help you to create a Kubernetes cluster in containers. And then it's very natural to use virtual wires, and it's very easy to go and connect elements, nodes in the Containerlab with the nodes that you have in the Kubernetes Kind. There is just a small issue that I'm gonna show you later, but that actually makes the things even way easier versus to use virtual servers. And I'm gonna show a demo. Is their videos, okay? I didn't want to bet and try to do something live. I don't know how the internet is gonna be working. But I had some videos, and you can see those videos later when this presentation is uploaded in YouTube. I tried to put it as much with big fonts, but hopefully you're not going to have a problem to see some of the command line examples that I have for that demo. And I'm going to show you how to install Containerlab, how to install Kubernetes Kind, and how to set up MetalLB, the load balancer service, using BGP. And other thing, important thing, I also was playing with the hashing for the load balancing with ECMP. Then you're gonna see actually you can control your load balancer service using ECMP. Okay, why? What are the Kubernetes native services or Kubernetes services? If you're familiar with Kubernetes, you have the concept of pod. Pod is just a network namespace in Linux. But in Kubernetes, they call it pod, and inside the pod, you can have containers. You can have one or more containers. And the idea of that is, I want to avoid any conflict to expose my applications, because every pod is going to have an independent IP address, okay? But there is a problem with that. Is because you have many nodes in the Kubernetes cluster and pods are moving around, and sometimes you have stateless applications working on those pods. If a pod, for example, is crashing and is restarted, probably is going to be restarted with a different IP address. And then what's going to be the problem is I need something more stable to address those pods or those set of pods, okay? And there you have, for example, the Kubernetes services that are going to give you that IP address that is going to be more stable. And they have their internal load balancing too. They work, cloud IP, for example, cluster IP works with a round robin, a very simple round robin. But you can actually install something more advanced like an ingress controller that it can have many other different ways to do that. And those services can work inside the cluster. For example, cluster IPs only, you can reach this out only inside the Kubernetes cluster. And you have also the node port that is going to help you to expose that service to the rest of the network. Then I'm going to go very quick on the different services. I told you about cluster IP. Cluster IP is a very common service. It's the default service that you have in Kubernetes. is all internal, and it's very easy to define. For anyone that is very familiar with Kubernetes, you just need to go define this through a YAML file, like you can see here, and then select the application or the instances of the application using any sort of label. Okay. But this is all internal. Why I'm going to need an internal service? Well, sometimes applications have different layers. You can have, for example, a database, and you can have your front end. Then the front end is going to be also, you're going to have many stateless instances. You need a cluster IP for that. And also you need a cluster IP for your database. And they can be working internally in the cluster, and you don't need to expose that information to the rest of the network. Okay? Then you have the node port. That is, this is also the service by default that is used to expose any service inside the cluster. Then the way that is working is, let's say you have a web server, and you need to expose that web server, and you have many instances of that web server. It could be a stateless application working, again, with a database. And the way that you're going to expose that is you present that in any of the ports that are over the 30,000 in all the servers. And in all the servers, it's going to be the same port. Then that way, for example, you're going to know that if I need to set up anything in my external load balancer, I just can go to that specific port. Then you can let the cluster to define the port, or you can specify the port inside your configuration when you define the service. Now, cluster IP is also being used by node port internally. Then everything, you need to think everything is actually defined. That exposition of the service is using IP tables. Okay, we call it kubeproxy, but kubeproxy actually is the agent that is managing the IP tables. Okay, then when you are exposing that, you're letting the cluster to just manage the IP tables in every node in order to expose that service in that port. But on top of that, you have node port, but under that you have cluster IP. Then when you have a node port service, you are actually defining two services, cluster IP and node port. Now let's talk about the load balancer. Load balancer service is the most popular Kubernetes service in the public cloud. Okay, but on premises is sort of tricky to just try to enable it. Today I'm going to show a way to do it, but it's also something that is coming very native on the Kubernetes services. And when you are defining the load balancer, you need to define the cluster IP, on top of that the node port, and on top of that the load balancer. And you have the three services. Then every time that you're defining the load balancer service, actually you are defining the three services. Okay. The load balancer is going to give you more control in the way that you're going to balance the traffic. You can also use ingress controller in the middle if you want to have application routing or SSL offload. You just need to use the ingress controller like your front end for your application. I'm going to show something like this later. How can I define a load balancer service, for example, in Google Cloud? Here you have an example. In this case, I'm not just defining the service, I'm also defining the application. That is just a hello node that is giving me just sending hello in a specific port, and I'm using 3 replicas of that, and I'm load balancing this directly in the public cloud. But like I told you, the public cloud, everything is connected. When you do this on premises, you don't have that. Another important thing about the load balancer service is the external traffic policy. Okay, remember that I told you that when you define the service, you have the cluster IP, the node port, and on top of that, the load balancer. Okay, when you define the external traffic policy, what is happening is when the traffic is coming through the load balancer, it's going to every node in every other port over the 30,000. And then it's going to a cluster IP. But the cluster IP can go to the pods that are in the same node or can go to the pods that are in other nodes. If you want to avoid that circling of the packets, you can just go and define external traffic policy like local. And then when the traffic is hitting any of the nodes, it's going to stay inside the node, and it's not going to try to go to other nodes in the cluster. Okay, but there is a catch. The problem with that is you don't have control how the pods are going to be distributed in the cluster. Then if you have, for example, let's say 2 nodes in the cluster, and you have 3 pods, one of the nodes in the cluster is going to get less traffic than the other, or it's going to get more saturated. Okay. Then the other problem that you're going to have is you decide, okay, I'm not going to use local because I want the traffic very balanced among the pods. If you define the cluster, it's going to obscure the source IP of the client. Then when you do the troubleshooting later, it's going to be a little of an issue. Okay. Then you need to choose any of those, but most of the time I'm seeing people using local because that keep the things easy for later for the troubleshooting, and you can control the amount of replicas, and usually if you have 4 replicas, you're going to have a well-balanced distribution of all the pods in the cluster. Then when you define the service, and this is an actual description of the load balancer service, you can see that you define the service is assigning, allocating an IP address from the address pool that you have set up for that load balancer. And you also have the node port defined. For example, you have a specific port here that is 32,142. And you have also the cluster IP that is going to all the endpoints that you have there that they are actual pods. Okay? Then if you go and describe the service, you're going to see something like that. In Ingress, there are people that is saying, well, Ingress is also a Kubernetes service, but it's not native. It's actually an application, and you can decide how many replicas you're going to use. And as an application, you can actually define a load balancer service just for this Ingress controller. I would say the most popular is Nginx. Okay. Then when you are defining the Ingress controller, here you have an example of application routing. Then I can go and define 2 services, node port services. You see that? And for those node port services, I'm defining in an Ingress controller an application routing that is for the same site, but is going to take my traffic from one page to one service, in the other page to other service. Then in that way, in microservices, you can have many different developers working in different applications, but they can be in the same site, and you can just do application routing using the Ingress controller. And also, you can do SSL offload with the Ingress controller. Then you have many layer 7 applications in Nginx or on the Ingress controller. Well, in this case, I'm showing you that I just installed a Kubernetes cluster, and when I try to use let me go back a little. Kubernetes does no, okay. I'm exposing an application, Python application, that is exposing the information of my pod and telling me in what node this is running in the port 8080, but it's a simple HTTP server. I'm gonna show a little more about that later. And then when I'm trying to set a load balancer service for that, I haven't prepared anything. This is a French install of a Kubernetes cluster. It's gonna show you that it's in a pending state, and it's gonna stay there forever because you need to go and set up that. Then You see that actually I'm showing you the pods of the hello node. And I have there the load balancer. I'm putting the external policy in local. I'm putting it's going to be a service type of load balancer. I'm going to try to apply that configuration, and I want to see the status of that service. You see that is pending. I haven't actually, didn't give me any IP address from the pool. Then the idea is now let's see how we can fix that. Before to go there, when you go to different customers, they're using, like I told you, Nginx ingress controller. Then they still relying on external load balancer to bring application routing on the application or SSL termination. They can use also traffic. HA proxy is very popular too, but it's not directly integrated to Kubernetes. You need to work on that. I couldn't find any open source project in order to make it work. And a MetalLB is not an external load balancer. It's working directly on the Kubernetes, but it's through the BGP that is exposing the the application is advertising the IP and putting the Kubernetes node like another neighbor in my fabric. That I'm going to show you that later. But this is why I like MetalLB, because it's very clean. You don't need to put something in an external device. Everything is inside the cluster. MetalLB has an option to work in layer 2. Personally, I don't like it too much because I think when this node, you need to put just one node getting all the traffic in layer 2. That is going to expose a service IP. And the rest of the nodes that are going to stay in a standby. As soon as one node is crashing, it's going to take maybe a minute, a couple of minutes for other node to take that service IP. Then it's not that clean in a failover process. Okay? And also you are concentrating the traffic in just one node. Then in the case of the BGP, what you're doing is every node in the cluster, Kubernetes cluster, is going to be a BGP enable for the leaf that is directly connected. You don't have bottlenecks because actually using ECMP, you are spreading the traffic all over the fabric. And there is an experimental option with BFD that I haven't tried in this demo, but be my guest. And you can also, when you define the traffic control in the cluster versus local, you can see the actual difference between one and the other on the pods. But yes, so this could be a problem too, because now Kubernetes is going to be another element in the fabric, another element in the network. And when you are actually setting everything through BGP, you need to also check policies between the Kubernetes nodes and the leaf switches. It's not just now in the network. You need to also put the Kubernetes another element in the network for the operation. And this is something that some customers didn't like so much. Okay? But everything depends on the operation team. For the demo, I use Containerlab. For who is not familiar with Containerlab, you can define your topology in a YAML file. Everything is going to be based in containers. You can work with multiple vendors. You can define your startup file for all the configuration of your switches or routers directly on that in a file that can be addressed directly on the topology file. Take just a few seconds to go and start up, unless you have too many nodes or too many files to address as the startup file. Maybe it's going to take more than 20 or 30 seconds. But it's pretty easy to use, and I like it because you have, in my case, I'm using SRL for this demo because you don't need a license. Okay, and then I was using SRL and just put it, and it was working right away. I even forget to pull the image in advance, but when I started the topology, the Containerlab actually forced to pull the image directly on the process and then start deploying everything. If you want to install Containerlab, it's pretty easy. I use Fedora. However, now I'm using Rocky, and Rocky is a little more tricky than Fedora to install Docker. You need to remove Podman, and then you can go and install Docker. Okay. Install Containerlab is just one command. And as soon as you have that, this tutorial that I'm doing right now is in GitHub. You can just go and check the documentation. I have all the information, the commands that I'm using here, over there. All the configuration files are actually there. And everything is open source, and then you don't need to have any specific license from any vendor. You can just go and start working with it. And when you clone this repo, you're going to have the topology file right away to just go and deploy it. And when you deploy this topology file, it's going to create a couple of spines, a couple of leaf, and a border leaf. And I'm also installing Prometheus and Grafana, because at the end of this session, I'm going to show you a visual how actually the load balancer is working. Okay? And I did that just because it's much easier to just see the command line, you know. With the inspect, you can see what actually you have. It's going to assign an IP address to every element for management. And inside the topology file also you do all the connections between the different elements in the fabric. Okay, for who is not familiar with Kind Kubernetes, this is a Kubernetes solution that is working directly on containers and is using Go. Then you need to install Go first. And it's also working with Docker. Then again, it's a little tricky for Rocky, but if you're using Fedora, it's going to use Docker right away. In the case of Rocky, you need to remove Podman and do like a reinstall of the Docker engine. Sorry. Okay, I did this so many times that in one moment I was putting everything in a batch, but even the batch wasn't enough because I have to go and change the batch every time that I was doing something new. Then I created a Go application. That was my first application in Go, to read all the settings directly from a YAML file. And then instead to go and create Containerlab here, create Kubernetes Kind over here, and then start manually going and connecting every element, leaf between worker node. What I did is I put everything in a YAML file, and with that, I just can go and change the YAML file, and everything that any change that I'm doing in that file is going to immediately be applied with that script, with that application. It's not perfect, okay? It's my first application in Go. Then if you want to contribute, go ahead. For me, it was more than enough to make it work, okay? And then in this case, the YAML file, what I did is I say, okay, I have all the relationship between the different nodes in Containerlab, but I needed the same between the Kubernetes nodes and the leaf switches. And then what I did is I put the same thing plus the IP addresses that I was expecting to have in every Kubernetes node. I also define more than one Kubernetes cluster. I put a Kubernetes cluster simulating the data center, but I have a Kubernetes cluster working as a client in the border leaf. Then I put two Kubernetes clusters, and I define the Kubernetes cluster using the configuration file, the YAML file for Kind. I use a specific image of Kind because it's still very early as an open source project, and they're doing many changes, and I don't want to run into a bug. And preloading all the images directly on the Kubernetes. You can create a private registry if you want, but I didn't want to bother myself creating a registry every time that I was creating the Kubernetes cluster, but it's up to you if you want to do it that way. And I put also some, I pre-installed some of the applications using the same script. And this is the script. Then something interesting in Go is it's very easy to put concurrent processes. Then as soon as I started to create the Kubernetes Kind, and I had a problem with Kubernetes Kind that I couldn't change the name of the network. Then I forced the Containerlab network to use the same name and put everything together in the same network. Why? Because I was using Prometheus push gateway in the same network with the Kubernetes Kind, and I have some issues with IP tables because Kubernetes Kind is changing some of the rules. Then I told myself, okay, I'm gonna put everything in the same network and then problem solve. But like I showed here, it was pretty easy. It's just you need to go address everything in a YAML file, run the script, and everything is gonna, in a few minutes, you're gonna have everything. Containerlab, Kubernetes Kind, it's gonna connect everything, it's gonna upload the images, and it's gonna install all the applications, including MetalLB. Then, what is the topology that I'm using here for this lab? And again, you can see this directly in the repo. I created a EBGP underlay. You can use ISIS or EBGP, it's up to you. If you wanna, I just wanted to work with EBGP. I have some customers, they're telling me, why you're using EBGP? You know there is a limit for EBGP entries in the fabric. Okay, well, you can use ISIS then and then use IBGP later for EVPN if you want. Then I define my EBGP underlay. You can see also how I connected all the workers, the Kubernetes workers with every leaf. And also I define a EBGP VPN for my network. And then here in this case, my MetalLB speaker through every worker node is doing the BGP peering with the EVPN domain, not with the underlay BGP. It's working directly with the EVPN because many customers are using VPN to have multiple domains and they have multiple Kubernetes clusters, and you don't want to put all the cluster working in the same, domain. Basically, I did that because of it. Well, just another review. Remember, every pod had a different IP address, and the idea of having that in Kubernetes is something you can have with Docker, because if you are working with Containerlab, what is the principal problem that you have with Containerlab? You can share, if you have two instances of Prometheus in the same, for example, topology file in Containerlab, you're going to see that you're going to have a conflict between the ports. Then the advantage of Kubernetes that is creating a pod for every container or more than one container for every application, and you can use the same port always. Okay. In config map is, well, when you have an stateless application, you can have the option to use config map that is a value or key value information that is going to be stored in the etcd database or stored in the Kubernetes cluster. And that information is going to be available for all the pods in the cluster. Then what I did is I set the configuration files of my application directly on a config map, and then that way from any of the pods I can just mount it as a volume and start getting that information directly from the config map. Also, MetalLB, well, lately they did some changes, but MetalLB is also using config map for setting everything up, okay? And then all the speakers are going to the same information in the config map. But lately, they've been working with another thing. Here, I put it here. This is an example of the config map for MetalLB, where you have you define what is who is going to be my neighbor, BGP neighbor, my peer ASN, and who is my local ASN. What nodes actually are gonna use for that BGP relationship. Remember, sometimes in one leaf you can have more than one worker connected to the same leaf, and in that case you want to use the same ASN for that peering, right? And because of that, I'm using labels. All the worker nodes in Kubernetes, they're using labels. Then you can identify those workers using labels. And you can set up also your address pool for your load balancer service. And I put here also a note that MetalLB is starting to use custom resource definitions, CRDs. Who's familiar with CRDs here? Okay. CRDs is something that applications like Nephew is a project coming from Google for the mobility. Probably later it's going to be extended to another use case in the network. But it's giving you an option to control, orchestrate the network using Kubernetes. And then your Kubernetes is going to be like your central application or central orchestrator for your network. But the custom resource definition, what they're doing, they're extending the same Kubernetes APIs. It's not just like another application. You're extending the same Kubernetes APIs to start addressing some elements more specific to an application. And the application needs to have an operator that can read that information, and based on that desired state that you have in your CRD, is going to make the changes on the application. Then it's a better way to do changes on your network, on your applications, because you know that there is going to be an operator reading that information. Then you can, for example, define a unique single or a single source of truth for all your application, for all your network, defining your desired state, and the operator is going to go take that information and is going to do the changes. And then make the things way easier. And also, when you're doing this with Kubernetes APIs, you had a big ecosystem in Kubernetes working with APIs. Then you can start taking advantage of that. Okay, for example, you can use Argo CD, and you can define your source of truth directly in GitHub. And then as soon as you make any change there, the CRD is gonna, the operator, the Argo CD is gonna make the changes in the CRDs, and your application is gonna apply those changes, your desired state, to your current state of the network or your application. Then making things way easier for developers and to create something like continuous integration, continuous delivery to work, to orchestrate networks, for example. Okay, but CRDs, I didn't put CRDs in this case. I'm still working with config map. This is why I put some specific images of MetalLB. But now they're starting to work with CRDs. They created their own operator and everything. And then here you can see this is the config map. And you can just go and apply the config map like you are actually applying any application or YAML file using the Kubernetes client, kubectl. Then you can define the pool address that you're going to use. And this is going to be the pool address I'm going to start exposing in my border leaf. Then you need to be very careful. It needs to be something that it can be, is not going to get any overlap, conflict with other prefix in your network. And then I'm just installing here the MetalLB. Is creating the speakers in the different workers, as you can see here, and then I can just go and check the logs of my speaker. And you see, I haven't applied the config map yet with the VGP configuration. And as soon as, and now I'm gonna start applying the BGP setup in the config map. And you can see now that the config map is being uploaded to the speakers. And now you can see that actually the VGP relationship are actually working right now. They're established. Then it's pretty easy. So you see it's only maybe 20 lines of code that you need directly on the config map, and everything is going to be sorted out in MetalLB. The way that actually this is working, in order to make this work, I have to create a EVPN, a layer 2 for the subnet, but I have to also define a layer 3 where I can have my loopback address for that specific EVPN domain. And this is being exposing directly to my border leaf, to another layer 3. It's part of the same layer 3 domain. And where my actual client is going to start hitting the application through the load balancer. Then again, I don't have an external load balancer. Everything is actually inside the Kubernetes. I'm using BGP to emulate that, and ECMP to spread the traffic across the fabric, the different leaf devices. Well, in this case, my Hello node is a Python application. I'm going to show you an example here, Hello World. If you want to define a simple HTTP server with Python, you just need those lines of code, and it's going to give you the Hello World in the port 80, 80, or 81, any port that you define directly there. It's pretty easy to run in Python. You just copy the code and apply Python, and you can see this with curl or directly with a browser. This is my Hello node. This is actually what I'm doing here. But in this case, what I'm doing is I'm exposing, with my Hello node, I'm exposing the host name of my pod, because I want to see if I'm hitting the same pod or different pod in the same Kubernetes node. And I also exposing the node where my pod is located. Okay. If I go and define my my Hello node, if everything is in a config map, I'm mounting that config map, the volume, and I create, in this case, for example, 4 replicas of that. And when I create in the load balancer service, I'm addressing that application through the label. You see, here I have this application label, and I'm addressing that directly using the load balancer with the same label. And here you have this in action. Then you can see the code of my Hello node. I'm creating the config map, and then I'm creating the replicas, my stateless HTTP server using that information. Give me a second. I'm going to start creating that in any moment. So this is my information that I'm exposing in that case. 4 replicas. And I'm using the latest Python. It can be any of the last releases. And now I'm creating you can see that I have the 4 replicas of my Hello node. And now I'm gonna create the service, the load balancer service. Remember, I just created the VGP relationship with the leaf and everything. And when I'm applying this load balancer service, I think I went too ahead on my slides. It's coming. Just wanted to show you that actually how to create the load balancer service and the hello node. But before to go further on this presentation, I'm going to show you the topology. Remember that I told you I created 2 Kubernetes clusters. One is for the data center, another is my client that is actually a standalone Kubernetes cluster that is my tester that is directly connected to the board leaf. Then the idea is why I did that, because in that way I can create many replicas of my client. And then and the IP is they are going to actually changing all the time, because this is part of the how actually Kubernetes work. And I'm going to show you later how they're using the hashing in order to make changes on how my traffic is spread through the fabric. And then as a tester, I'm using an open source project called, I think it's, hopefully I'm not mispronouncing that, but it's Cassowary. And I like this project because you can actually get more stats from more directly related to an HTTP server. And you can use Prometheus push gateway to expose more information. I'm not using that in this moment, but if you're interested, you can let me know. I can show you how. And I just put this as a command. I put more than one container actually in the same pod. And I going directly to the address that has been exposed through the load balancer. And for the hashing, and this is a little tricky here because the hashing is very tied to the hardware. And at first, it actually didn't work. And then I realized that I need to define a hashing base in the source address of my client in order to have a real spread of the traffic among the different nodes. This is only because this is a container. In the case of a hardware, it's going to work right away. But because it's a container, you can use hashing based on hardware, okay, for your ECMP. Then in this case, I only define my source address as my hashing method for spread the traffic in my fabric. I'm defining 4 replicas for my client. Again, I told you this is another Kubernetes cluster for that is going to work as a client directly connected to my border leaf. But I can go, you're going to see that I'm going to be playing with the replicas later. Then the idea is I can just go and start defining multiple replicas of my client, and through the border leaf, it's going to be spreaded to different nodes and pods in my cluster. And the way that I'm going to control that is using the hashing option that I have in my border leaf. Then I'm going to show you some of the settings that I have on the switches too here. And here you have the hello node, and the load balancer actually is working. And you can see that actually the hello nodes are in different workers in my cluster. They have different hostname too. It's important to see the hostname because I'm going to expose the hostname later. And I'm going to go to my Kubernetes client now. And in my Kubernetes client, I'm going to get into the pod of my that I'm using as a tester. You can see the process is actually working there. But I'm trying to manually go and connect the HTTP server. And now I'm just doing that like 20 times to see if actually the load balancer is working. And you can see that I'm seeing different host names and different workers being exposed for the same destination. Then the load balancer actually is working. Okay. I'm going to show you later this in Grafana that is a little more visual than just seeing the command line. I'm getting into the leaf to show you how actually the neighbors are working. You see that actually I have the MetalLB speaker connected to my my leaf. The VGP is established. And in my border leaf, you see that I only need to connect to the leaf. I don't need to expose anything from the Kubernetes to the border leaf. Why? Because I need to force that it can take any of the routes to any of the workers through any of the leaf. And because of that, when I create in the load balancer, you can see now I have two options as a route for that destination. Then for testing the load balancer, well, I'll show you the way to do that via command line. But the idea is now what I'm going to do is using my client, I'm going to go and start changing the replicas of my client to see how the traffic is actually spreading and how my hashing actually is working. Okay. And for that, I'm going to use Grafana to visualize that information. In this case, I'm using GNMIC to extract the information from every interface that is directly connected to the to the worker node in every leaf. Then what I'm gonna do here, well, you can see that the traffic has been actually almost evenly spread between the different nodes. And in this case, I'm showing the one of the port, I think it's the port 10. Yeah, the port 10 in the first leaf and the port 10 in the second leaf. And in that way, I can see how the traffic actually is coming from the tester. And now I'm going to start changing the replicas of my client to see how actually my traffic is going. It's been spread in my data in my fabric using the hashing that I define in my border leaf. Then I was using 12 replicas. I changed that to 4 replicas. You see that actually I'm terminating the rest of the replicas, and I'm gonna stay only with 4. And with 2, sorry. And then the traffic should be going down now, and you're gonna see if using the hashing that I have, if it's those 2 clients actually the traffic is hitting different workers, and you can see that actually working like this. I'm fast forward. I did the fast forward the video because it was a long time waiting for that, and it's working really nicely. But now I'm gonna try to go back to more replicas and see what is gonna happen. Again, Kubernetes is always changing the source IP address because every time that I recreating a new pod, it's gonna change the address. Okay, it's not gonna be the same address that it used to be before. Then I'm using that in my advantage right now. And then I'm creating 10 replicas, and it was taking about 45 seconds. Then I fast forward that. And you see that now the traffic is being spread again, and there is more traffic coming to the workers. But for some reason, the hashing wasn't working in a good way. Then you can see the source IP could be working sometimes, and sometimes it's not the best hashing option that you can actually manage for your load balancer. And then probably you're going to use this your hardware because this is a container. It's going to show something totally different that I'm actually having here. Okay, but with this I'm showing you. And another thing that I have to do is with EVPN. When you are getting, you are also advertising the information of your type 5 routes. I got the problem that in some moment it was always choosing one route for my load balancer for my application, and then I have to create a policy to avoid the type 5 route to go to my border leaf. With this, I was forcing the border leaf to only have to show me all the options that I have for all the leaf. Otherwise, it's gonna always go and choose one. It's gonna show me only one. Okay. Okay, and then basically what I was showing here is, you see, I don't have an external load balancer. I'm using the same Kubernetes cluster, using the speakers that I have in every worker, connected through BGP with my leaf. You can have full control of your load balancer using your fabric. Then you don't need to bother even talking with the guys in that are creating the load balancer service in the cluster, because you can say, okay, this is your address pool where you can start defining, exposing your application through the load balancer, and you can start seeing how everything actually is working directly on the fabric. Okay, and you can have control of how the things are the traffic is spread on the different leaf, on the different elements in your fabric, using a hashing algorithm directly on the border leaf. I did this same thing, but I was working also with segment routing and put some routers, additional routers on this solution. But I didn't want to put it over here because for the routers I require a license. But it was also very, very nice to see how you can have control of how the traffic is coming to my cluster, only touching things directly on the fabric. Okay, and it was a very easy way. It was very easy to implement something like that, and you don't need to bother yourself trying to go to a specific port or doing any manual settings. After every time that someone is exposing an application through Kubernetes, and it's very automated. And there are additional resources if you are interested to see a little more about that. There is a very good presentation of Grafana in Nano YouTube channel. Also, Karin and Roman, they did a really great tutorial for Containerlab. For someone that is not familiar with Containerlab, you can go directly in the Nano channel in YouTube. There is another, also Karin did another tutorial for GNMIC if you are interested to pull information, telemetry, and use Grafana to expose that information. And I did, like, I think in Montreal, I did a Kubernetes 101 for network professionals if you want to know more about Kubernetes and understand how everything is working internally in the network. And time for questions. Could be any question.
Hello,
Hello.
Tony from DevBox, and congratulations. That's really a great presentation. So you've implemented this in Containerlab.
Yeah.
How would I implement this on live infrastructure?
Okay. Well, you can, if you have what kind of technology, Cisco, Juniper, whatever you have, hopefully you have Nokia, no, just kidding. Then anything you have, basically we are talking about EVPN, BGP, ECMP is very standard from the point of view of the protocols. In the Kubernetes, you need servers, but I like Containerlab because I don't need to buy or acquire servers in order to make it work. You can have, you are gonna need at least 2 servers in order to make it work, because you need someone to be the 2 workers to start spreading the traffic at least in 2 different points, okay? And then with 2 bare metals, maybe it's gonna be more than enough to simulate the data center Kubernetes, connected to your leaf.
Okay, thank you. Can we contact you for questions?
Yes, of course.
Awesome.
Yeah.
Hey, hi.
Hi.
Mohibul here.
Hi, how you doing?
Yeah, good. So my question is, like, can we try the lab in the cloud environment? The lab you done here?
Yeah, the lab is in repo in GitHub.
Mm-hmm.
Then You can just go and clone that repo everywhere. In my case, I was using just a bare metal server, 128 gigabytes of memory, 20 cores of CPU. And for me, it was more than enough to run everything, and I start playing around with this. In your case, I would recommend to try, well, no, you can actually use a virtual server for that because you don't have any nested virtualization. The problem if you're using, well, everything depends of the router that you're going to use, because if the router actually is based on a QEMU file, and then you're going to run into nested virtualization, and I don't recommend you to try to work with something like that or work around something with that. Then I would recommend you to try to have a bare metal server. Could be in the cloud, it could be on premises.
Cloud also fine, right? Okay.
Yeah, could be in the cloud. But I would recommend that bare metal. If you want to work with SRL, it's going to be fine to work in a virtual server. If you want to use another solution, but it doesn't have a native image, a cloud native image, you're going to run into problems with nested virtualization.
Yeah, another question.
Yeah.
So actually, what are the solution you are trying to implement, or what the problem you are trying to solve? Just could you give a high-level view?
Yeah. Well, basically is when you install Kubernetes on premises, you have the load balancer service, but it's not working.
Okay.
And when you want to implement that, it's a little tricky because not all the solutions are actually natively integrated to Kubernetes. And you go to the public cloud, it's working right away. Any Kubernetes you define in public cloud is working because it's actually integrated with the load balancer. When you go on premises, you don't have that. Then unless you want to go and do everything manually with your external load balancer, I recommend to use something like that because you don't need an external load balancer to use something like this. And you can have all the control in Kubernetes and have visibility directly also in your fabric, working with BGP and ECMP and the hashing options so you can have in the fabric.
Yeah, it is very interesting to see that implementation of BGP in Kubernetes with Kubernetes. So personally, I was a network engineer and actually transitioned to the cloud. So very interesting. So actually, what's the role of BGP here, with Kubernetes?
The role of BGP is when you are defining a load balancer service, let's say you have a prefix that you want to use to expose your applications to the rest of the world, okay? You had a public prefix, okay? But the problem that you have is you need to expose it in some way, and you are defining this directly in the Kubernetes. When the Kubernetes actually is doing through the BGP is you go to every time that you're going to expose an application, you go and take an IP of that pool, and the BGP is advertising that IP address up to the border leaf.
Through iBGP or?
Through BGP. And the border leaf now have information of that IP address and all the routes that I need to go and hit that application in the cluster.
Okay. I think.
You're welcome.
Hi, Chris Whitfield, DriveNets. I'm not only the moderator, I'm sometimes also a questioner. But I actually got up to the microphone to address your question, which is how well these labs run in cloud environments. The better answer is that as long as Containerlab works perfectly well in an EC2 instance, in any sort of virtual machine, as long as the OS images that you're running on it are containerized. If your Containerlab supports virtualization, but you can't run a VM inside a VM. You can't nest virtualization. So yeah, SR Linux runs perfectly well. CRPD, Arista, CEOS, but not VEOS and not VMX. So just check the image you're running, make sure it's a containerized image and not a virtual image wrapped in a container, and you'll be fine.
Yeah, you don't want to run in nested virtualization. It's very complicated.
Hi, Fabio from ix.br. I'm running MetalLB as L2 service in my environment. But
Could you repeat it?
I'm running nowadays the L2 version in my environment. But if you take a look in their website, at MetalLB website, they say that it's still a young project and it should be treated as a beta service, right? Beta
Yeah,
project.
you're
So
right.
do you know some large clusters that are using MetalLB already?
Yes. There are a few companies that are offering packet core solutions using MetalLB inside the architecture. I can't give you names, but
Not.
I know that for certain that actually they're using this.
Thank you.
On the on-prem setup, can we use ingress, like ingress object?
You can use Ingress controller to replace the hello node, for example, the application that I have. Yes, of course.
Okay, thank you.
Douglas McDuff, i3d.net. In an analysis I was reading of various load balancing platforms for bare metal Kubernetes deployments, I saw something about MetalLB doing the BGP not supporting v6. Is that the case currently? No offhand.
Well, this is a good question. No, I need to research a little more to answer that.
Okay.
So far, I've been testing everything with the IPv4. Yeah, I think maybe I saw something lately in the web page that they're trying to do something with the IPv6, but I'm not sure for
Okay.
right now.
Thanks.
I need to check. Thank you very much. Have a nice rest of the day.